Hi, my name is Jamie, and I'm with Chegg Tutors. Today I want to talk to you about the properties of circles. Now these may seem very familiar, but I want to get you familiar with not just the geometry or the definition, but also the algebraic or coordinate expressions that define a circle. So here we have a coordinate plane with x and y axes and a circle centered at the origin. That means the center of the circle in xy coordinates is at 0, 0. The circle has a radius of r, which means that any point on the circle has a distance r from the center of the circle, which in this case is the origin. Now, just to make it clear, this circle is also defined by the idea that it is every point that is an equal distance from a certain other point. In this case, every point that is a distance r from the origin is part of the circle centered at 0, 0 with radius r. So there's a geometric definition of a circle, which we used in compass and straight edge constructions. There's also this coordinate definition of a circle. Now, if we're thinking about the coordinate definition, which we usually are as we go from analytical geometry to pre-calculus to calculus, we have the Pythagorean formula for distance. So the square root, so the x-coordinate is this coordinate here, the y-coordinate is this coordinate here, and by the Pythagorean theorem, x squared plus y squared, the square root of the two coordinates for a point x, y on the circle, is simply the radius squared, r squared, since r is the hypotenuse of this right triangle. If we square both sides, we get that the equation for the formula of a circle centered at the origin is x squared plus y squared equals r squared. That means that for any point, it is on the circle of radius r centered at the origin if its x-coordinate squared plus its y-coordinate squared is the radius squared. Now, one other point I want to make about the circle is that this point, for example, is in the disk. It's in a area of radius r with boundary of the circle of radius r in the coordinate plane, but this point would not be on the circle. X squared plus y squared here is less than r squared. The circle is a one-dimensional thing that is simply the boundary of any kind of area that we find in the coordinate plane. Now the question is, how do we convert? So most times circles will not be circles at the origin. They won't have radius 1, or they won't be centered at the origin. They'll be centered at some arbitrary coordinate somewhere in the coordinate plane. Say that coordinate is a comma b. The x-coordinate is a for the center of the circle. The y-coordinate is b. The radius is still r here. We can very simply transform the formula for a circle with the center at the origin to a circle at any coordinate by noticing that if we convert x to x minus a here, then a becomes 0, so the x-coordinate becomes 0. If we convert y to y minus b, the y-coordinate of the center becomes 0, and then we just have an equation for a circle with center at the origin. So with this conversion, x to x minus a and y to y minus b, we get that the general formula for a circle is that x minus a squared plus y minus b squared is r squared. All I've done is replace x by x minus a and y by y minus b. This is really useful because we don't get to choose our coordinate system all the time, but we do get to convert very easily when we've simply shifted the circle some units right or left and up or down from the origin. This is just a very brief introduction to circles, but more later, and thanks for watching.